Hello, welcome to this crash course on Prepositional Logic. So, the aim of this crash course is to take you through everything you need to know about Prepositional Logic. So, at the end of this video, you should be able to construct truth tables on your own and prove logical equivalences and the likes of it, right? So, what is a prepositional statement? Well, a prepositional statement is a declarative statement, right? That can either be true or false. So, Ghana is a country. That is true. So it evaluates to true. And now these prepositional statements can be represented with letters, right? So you see you have a G, you have a H over here. That represents the prepositional statement. We have the second one, France is a town. Is France a town? It's not a town. So it evaluates to false, right? Then we have simple statements and compound statements. Now with a simple statement, right? It's what I just introduced you to right now. That is, Ghana is a country. Right? It's just a statement. Then we have France as a town. It's also a statement. But with compound statement, it has to do with a combination of two statements. Are you there? And this can be done with what? The logical connectives. So logical connectives is like conjunctions in English, right? The conjunction links what two simple sentences together to form a compound sentence, right? Yeah, I need to slow down. So it links two simple sentences together to form a compound sentence. That is a conjunction. But a connective does a similar job of linking two simple statements together to form what? A compound statement, right? So we have the end connectives. These are 5 connectives you need to know. We have the end, right, which looks like this. Anywhere you see this, that is the end. We have the or, which looks like that. We have these 3 signs representing the not, which is also the negation, right? Then we have the conditional. So with a conditional, there has to be a condition. Right? There is a condition involved. If it rains, I will take my umbrella to school. So you only take your umbrella if it rains. That is the condition. It has to be met before your umbrella will be taken to school. And we have the biconditional, right? So the biconditional is also similar to the conditional, but it goes both ways, right? I will take my umbrella to school regardless of the weather. Are you there? Okay, let's see if we can make that work. So if it rains, you will take your umbrella to school. If it doesn't rain, you will still take it to school. So both sides prove to be right. Okay, this is not the best. This is not the best one to use. Okay, this is not the best one to use. Okay, let's use one that's more common. It occurs in this real world. If Kofi is a boy, then Kofi has a penile structure, right? So if Kofi is a boy, he will definitely have a penile structure. You know what a penile structure is? The penis, right? So if Kofi has a penis, my cameraman is laughing. Cameraman, we won. If Kofi has a penis, then Kofi is a boy, right? And if Kofi is a boy, then Kofi has a penis. Are you there? So that is the word, the biconditional. That is how it works. Good. So I believe that is it for the connectives. Now we are moving to the real star of the show, the main star of the show. This is where the action begins. Truth tables. So with a truth table, it's made up of what? Rows and columns, right? And it's used to prove logical equivalences, right? Or it's used to evaluate them. Let me put it in that way. Yes. So with the truth tables, as I said, it's made of rows and columns. But how do you actually construct it? Right? Here you see it's already constructed. So how did I do it? Is it just a bizarre something, or I just select the number of rows or the number of columns I would love to use and just do it, or what? No, that is not how it works. Let me clean everything and start it all over again. So you have to look here and ask yourself, how many letters do you see? Right? The letters represent the declarative statements. We have P, we have R. It's only 2. You start P, you have your R. Then what's next? What connectives do you see? You see 1 and 2, right? But you have to ask yourself, what is the main connective you see over here? Or is the main one I see, right? Because it's linking P and what? R. So it means you have to construct a truth. It needs to have a column on its own. That's what I'm trying to say. So P or R. Let me start separating. make P all like this. Very good. Then the next one is what? The negation, right? Or the not connective, which covers the entirety of what? P or R. So not P or R like this, right? Good. Now we have been able to what? Tell the number of columns there needs to be. But another question has been raised. How do we know, right, the number of rows to be used? How do we know that? That is a good question. Now there is a relation that helps us to do this, right? 2 raised to the number. 2 raised to the number. Okay, who is that disturbing us? So 2 raised to the number of what? The statements you have present, right? We have 2 statements, and that is the P and the R, so 2 letters. So this 2 raised to 2. So 2 to 2, 2 to the power 2 is 4, right? What if you had 3, like P, R, and S? So 3 statements is going to be 2 to the power 3. So this 2 is a constant, as you see there. 2 to the power 3 is 8, right? What if it was 4? You're going to have 2 to the power what? 4. Are you there? So here, since there are 2, right, which is P and R, 2 statements, you're going to have what? 4 rows, right? Meaning 1, 2, 3, 4. Just like this. So yes, that is it. If you didn't really understand it, go back and watch it again. Okay. So now, how are we going to start filling it in? Or you can decide to use the Boolean way, or you can just use true, false, true, false, true, false, true, false. Now with Boolean, you can use a Boolean expression. The Boolean expression is in the form of 0 or 1, right? Where 0 represents false and 1 represents true. Or 0 represents no, 1 represents yes. Yeah. So we are allowed to use a Boolean. Wait. So you can decide from a direction, right? You can decide a direction to start from. So I want to start from the R, right? So I start with 0, 1, 0, 1. That is how you start usually in the beginning. You just alternate 0, 1, 0, 1 like that. But if you move to the next statement, you are going to double down. What do I mean? This 0, right? If you double it, you're going to have 2 zeros, right? So 0, 0, right? What is next? Since we are alternating, 1 is going to be 2 times, right? So we're going to have 1, 1, just like that. So 0, 1, 0, 1. If you move to the next one, you double down, 0, 0, 1, 1, right? If it were to be 3 statements, there's also a way you would do that, which I would do in this crash course. So P or R, how are we going to evaluate that? With the or connective, right? It evaluates to what? True. When either side is what? True. So if one of them is true, it's going to evaluate to true. But if both are false, it's false. Right? So for it needs only one of the statements to be true for it to be true. Or it can be true if the 2 are true. So let's do it. 0, 0. They are both what? Not true. So it evaluates to 0. 0, 1. 1 is true. So it evaluates to what? True, which is 1. 1, 0. One of them is true. So it evaluates to true. 1, 1. They are both true. So still, the condition has what? Been met. Then we have not P or R. Right? So you can decide to do it P or... No, you can't decide to do it that way. Because you've already simplified the job by constructing the table for P or R, right? So now what you do is just to negate that aspect. So we just look at this part. Then you negate it. So not P or R. So not this 0 is going to be 1. Not 1 will be 0. Not 1 is also 0. Not 1 is 0. So that is it for this part of it, right? This particular truth table. Now let's try more complex truth tables. I saw a question I think is quite complicated and yeah. Okay. So construct the truth table for not P implies not Q. So we should construct this truth table. First of all, you ask yourself, how many statements do you see? 2 statements, right? So we start. We have our P, then we have our Q, right? Then you ask yourself, well, what is happening again? You have not P present, right? You have not Q present. So it means we need to have what? Columns for that. Not P, then you have what? Not Q. But that is not all. Now, the main connective that connects these two, that is the what? The conditional, right? You need to have a column for the whole thing. Not P or not Q. Good. So how many rows are we going to have? Since there are 2 statements, we have what? 4. 1, 2, 3, 4. Good. So as I mentioned earlier, right? You can decide to start from here or start from here. I don't know why I like to start from the back, but that's just me. 0, 1, 0, 1. Yeah, you have 0, 0. We double the 0 down, then 1, 1. Right? Then move to not P. So this is P. Let's negate it. Not 0 is 1. Not 0 is 1. Not 1 is 0. Not 1 is 0. Not Q. Same thing. We're going to alternate. 0. Not 0 is 1. Not 1 is 0. And like that. Not 0 is 1. Not 1 is 0. Good. Then we have not P implies not Q. Right? So not P implies not Q. That's what this means. Or that's how you read it. So what is not P? This is where not P is. This is a column. Then what? Not Q. So we are dealing with this too. Right? So for this implication operator, I'm going to show you a shortcut. Right? What is that shortcut? Look for the premise. Now, what is the premise? This not P is a premise. Look for wherever it is what's true. Right? Where is it true? Here it is true. Then look for where the conclusion is false. So in terms of this implication connective, right? When you are dealing with it, this first value is called the what? The premise. And the second one is the what? The conclusion. Okay. So look for what the premise is what true and the conclusion is false. Let's look through. We only have this instance, right? But the premise is true and the conclusion is false. So what are you going to do? That is the only scenario where this whole expression is going to be false, which is 0, right? All apart from that is true. That is it for this. That is how you deal with it. That's simple. So look for where the premise is true and the conclusion is what? False, right? So here the premise is true, conclusion is false. That's the only time where it is false. The rest is true. So that is it for this particular truth table. Now let's look for something more complicated. Okay, I have an example like that. This one is quite lengthy. This seems the table was already been drawn. No, I'm just going to scratch this because it's unnecessary. I've already proved my point. I need you to be equipped with everything in my ass now so you can tackle any question. Okay. What's this particular question I am looking for? Right, pause the video, give me a second. Okay, you just leave it like that. Yes, so excuse me, I'm trying to look for a particular question that we can use. So far we've done it all. Why is it so hard to find it? Hey. Okay. If we are not going to find it, then it means I have to create my own for it. It's about the inverse, converse, and the contrapositive of an implication. So, implication. And what is an implication? This is an implication. P implies what? Q. Right? So, there is this shortcut I use to identify them. I is implication, C is the converse, right? I C. I again is inverse, and C is contrapositive, right? So if you take the converse of an implication, it simply has to do with what? Reversing the position, right? So you're going to have what? Q implies P, right? So it's a reverse. You see that? Then, what about the inverse? Now, the inverse has to do with what? Negating it, right? So, it has to do with negating. Wait, negating what again? You are going to take the implication, right? So, not P implies what? Not Q, just like that. Negating it. So, you see, since it's I and I, these I's have to be two. These I's have to be the same. The only difference is that what? One of them is negated throughout, right? Then if you take the contrapositive, what's the contrapositive about? It's about you reversing the position of the what? The inverse. So you're going to have not Q implies what? Not P. Not Q implies not P. So how do these relate at all, right? The inverse and the contrapositive are always logically equivalent. And the converse and the inverse are also logically equivalent all the time. Yes, I believe. Right. So how are we going to construct truth tables for those? Let's work on it. So if I say, okay, let me set my own question. Prove that the converse and inverse of P implies Q are logically equivalent. Right? How are we going to do that? First, we will need a truth table, right? So our values is what? Our values are what? P and Q, right? So what at all is the inverse? This is the inverse, right? So let me make it, maybe it's not clear over here, so let me make it very clear over here. Not P implies not Q. Then what is the converse? Q implies what? P, right? So we have to prove that these two are equal. So we can see not P and not Q, meaning we need to have values for not P and not Q, right? And here, we are going to have 4 spaces in terms of the rules. Good. Now what again are we going to have? We need to have the actual implication, which is P implies. It's not even really necessary because you're not going to do anything with the implication, right? We need the converse, which is Q implies what? P. Then after that, we need a side forward, not P implies not Q. Just like this. Good. So P and Q, we're going to have 0, 1, 0, 1, 0, 0, 1, 1. Yes, at this point, this aspect is child's play, so I won't even go through it again. Not P, right? You're going to have what? 1, 1, 0, 0. Not Q, you're going to have 1, 0, 1, 0, right? Then what about Q implies P? Now I said the only time something like this, right, involving what? The conditional operator, the only time it is false is when the premise is what? True and the conclusion is false. So let's look for when Q is what? True and what? The conclusion, which is P, is false. Now you see this time I'm evaluating from Q to P. It's because it's going from what? Q to P. Are you there? It's going from where? Q to P. It's moving from Q to P, right? So at this point, the premise is true, then a conclusion is what? False. So that is the only time where that part is going to be false, right? So 1 and 0, 0. Apart from that, the rest is true, right? Then what about not P implies not Q? The only time that conditional is false is what? If the premise, which is not P, is false. So when it's not P, if the premise not P is true, which is here, right? It's true here, it's true here. And if the conclusion is false, it's true here, but it's also true here. It's true here, but it's false here. So here meets our requirement. The premise is true, but the conclusion is false. So it's going to evaluate to what? False, which is 0. Then the rest is what? True. Now if you take a good look at what? This 2, right? That is the converse and inverse of the implication. You can see that they have the same truth values, right? That is 1, 0, 1, 1, 1, 0, 1, 1. So hence, the converse and inverse of an implication are logically equivalent. So we have proved that. Right. So that is it for this crash course. I hope you enjoyed it and you took a lot from it. Yes, I'll be seeing you in the future. Peace.